Hey everyone, in this lesson we would like to discuss how to use the maximum power point tracking controller inside the PV system, or what is the function of the maximum power point tracking solar charge controller inside the PV system. So first we need to understand the PV or PI characteristics inside a PV system. So you can see here we have the current and we have the voltage, the relation between each of them at a different power or at a different radiance or the irradiation of the sun. So as the irradiation increases, you will see that the current, you will see that the current here is increasing, and at the same time the open circuit voltage increases a little bit, but the current increases very high. So you can see that here this is each of these curves represents the relation between the current of the PV panel and the voltage of the PV panel, both of them the output current and output voltage of the PV panel at a different irradiation. So as the irradiation increases, the current and the voltage increases, and in the end the output power increases. Another curve which shows the power versus the voltage or the current. So the one which with the diamond or four side shape, this one, the diamond shape is the P versus I. This one. Each of these, let's use the pointer. Each of this diamond, this curve, the curve here representing the relation between the power and the current. The circle one is the relation between the power and the voltage. Power is the output power of the PV panel at a different irradiation. So you can see that as the irradiation increases, the curve goes up, and the output power increases. Now we'll see that there is a certain point here, this point, at which the maximum power is produced. This point, for example, this point is the maximum power of this curve. This point have a certain power, maximum power of the PV panels, and a certain amount of voltage. And at the same time, for the same curve, for the same power here, we have a certain amount of current. So you understand from here that for producing the maximum power of the panel, we have a certain voltage and a certain current. So the current voltage behavior of the solar panel depends on the solar irradiation or the irradiance. Here you can see that as the irradiance increases, the current increases and the output power also increases. And also depends on the temperature. If the temperature increases, the output power decreases, as we discussed in our course for solar energy. As you can see here, as we increase the sun irradiation, and decrease the ambient temperature or the surrounding temperature, both of these conditions will produce higher output current, higher voltage, which means higher maximum power or higher power generated. So the environmental condition variations change the maximum output power of the solar panels. You will see that here, as the irradiance increases, the power output from the panels increases. Now here we have a simple PV system for a grid connected PV system. We have at the beginning our PV array, which produces a certain amount of voltage and certain amount of current, which depends on the irradiance and the temperature. Now the output voltage and current goes to a converter here or a solar charge controller. If we have a batteries, then we will have a solar charge controller. What is this part or the solar charge controller here? It consisting of a DC to DC converter. It takes the voltage here and converts it into another voltage. So the DC to DC converter, for example, if it is a buck converter, what does a buck mean? It means a step down DC chopper. So what does it do? For example, if we have here, for example, 100 volt, it will step it down to, for example, 20 volt. Okay, by changing something inside the converter called a duty cycle. By changing the duty cycle, we can change the output. Okay, so let's make it easy here. We have, for example, here V1. Okay, here plus minus V1. V1 is the voltage from the PV array. And here we have the output called V2. Okay, V2. For example, here if we have a step down DC to DC converter or a buck converter, then the relation between them will be V2 equal to V1 multiplied something which is called the D or the duty cycle. So V1 is the input here and V2 is the output, and D is called the duty cycle from 0 to 1. Okay, now by changing the duty cycle, for example, if we have here a V1 of a 20 volt, for example, and forget about the rest of the system. Okay, assume that V2 is an open circuit. Okay, we don't know the rest of the system now. So 20 volt, and for example the duty cycle is 0.5. Okay, so the output of the DC to DC converter will be 10 volt. Okay, so now we use the duty cycle to convert the V1 of a 20 volt into a 10 volt. Okay, the output here is a 10 volt. Okay, now this is one of the types of the DC to DC converters. All of these converters have been discussed in our course for power electronics, but for now let's see what we have. So now we understand that if we have an input, a constant input, a certain amount of input, by using the duty cycle from 0 to 1 in the buck converter or the step down converter, we can change, for example, from 20 to 10 volt. Okay, now in the PV system, what happens, or what we do? Okay, what is the benefit of the buck converter here? Inside the PV system, the V2, this V2 is connected to batteries. Okay, connected to a group of batteries. Okay, these batteries can, for example, have a voltage of a 24 volt or can have a 48 volt. Okay, 48 volt, this is the voltage of the batteries, or 96 volt, and etc. So this voltage of the battery, 24, 48, 96, all of these are a constant value. So here V2 is a constant value of a 24. Okay, now what happens here? By using the buck converter or the boost is the step up DC chopper, or a buck boost. Buck boost does the two functions, buck or a step down and a boost converter. Now for example, inside the buck converter, we can, this V2 is the output here connected to a battery. This value is a constant. Okay, we can't change it, we cannot change this voltage. Okay, now by using the duty cycle, we can control the V1 which is the output of the PV array. So let's make it easier. Let's delete all of this. So for example, if we have here this one is V2 and this one is V1 as we discussed before. Now assuming V2 is a constant value, so V1 is equal to, which is from the PV array, is equal to V2 over the duty cycle D. Now this value is a 24, okay, a constant value of the batteries. Now by changing the duty cycle, we can change V1, okay, V1, which is the array voltage. So what is the benefit of this? We can change the duty cycle until we reach V1, which provides the maximum output power. Okay, so you understand now the benefit of the converter here is that we take the output of the batteries, which is a 24 or a 48 or a 96, and by using the duty cycle inside the converter itself, we can change the V1 or the output of the PV array. So naturally the PV array voltage depends on the solar irradiation and the temperature. So as you see here, okay, neglect the rest of the system now. We now concentrating this video on the output of the PV array or on the maximum power point tracking. So if we look at this figure, okay, okay, you can see the relation between the voltage and the power, which we discussed before, at a certain irradiation. So we'll see that at a different output voltage, this voltage is the voltage of the array, PV array, okay? This voltage is the PV array voltage. And you will see that here, for example, at a 15 volt of the PV array, for example, or a PV panel, at a 15 volt, if we go up, we will have a power of 700 watt, okay? But for example, this panel produces a maximum power of a 250 watt, okay? One panel produces the maximum power of a 250 watt at a voltage of a 32, okay? So if we leave the PV panel to the atmospheric conditions or the temperature and the certain irradiation, for example, the panel will produce a 15 volt or any kind of volt, for example 5 volt, for example, let's make it easier, 5 volt. So the 5 volt will produce 150 watt, okay, if we leave the battery the PV array PV panel like this, okay? But actually the PV array or the PV panel here produces maximum power of a 250 watt at a 32 volt. 32 volt, I would like to get the 32 volt in order to produce the maximum power, okay? So here we have a panel connected to the maximum power point tracking charge controller connected to the battery, okay? The battery itself voltage have a 12 volt as a battery voltage, okay? This is a constant value. The output here is a constant, okay? So if we make the panel voltage at 12 volt, for example, okay, then we will have a certain value less than the maximum power produced, okay? So to make it easier, okay, we can just neglect this. This curve is at a nominal voltage of a 24 volt, okay, but this one is a battery of a 12 volt, okay? So what we can do is that we can draw another curve like this, okay, like this, for this maximum power point tracking system, okay? For this panel, we will have a 250 watt at a certain voltage, which is the maximum power here from the characteristics of the panel, 32 volt, 32. This is the voltage and this is the power, okay? So the panel produces the maximum power, 32 volt, at a 32 volt, produces a 250 watt, okay? Now if we use the nominal battery voltage here, 12 volt, then at a 12 volt, we will have a certain power, that 12 volt here, 12 volt, go up like this and produce this amount of power. This power, for example, can be at 200 watt as an example. Okay, so at the 12 volt, we will have a 200 watt. So this is not the maximum power. So we need to change that 12 volt here to 32 volt in order to produce the maximum power. So the maximum power point tracking takes that 12 volt here and converts it as the input to 32 volt in order to get the maximum power of a 250 watt. Okay, so it takes that 12 volt and changes its own duty cycle in order to get a 32 volt as the input. So the voltage here is the variable and this one is the constant value. So now, since we have a 32 volt and convert it to 12 volt, now we have a maximum power going to the batteries. Okay, now here is another example. You can see this. Now let's have an example here. You can see that here this curve representing also the PV array. Here a PV array, for example. Now if we are using the battery voltage of a 24 volt, for example, here at 24 volt, for example, what will happen if we make the panel voltage at 24 volt? The output power here will give us nearly 1250. Okay, so now by using the maximum power point tracking, by changing the PV array voltage to 32 volt, for example, this will give us the maximum power of 1500. Okay, so here this is the boost or additional power using the maximum power point tracking. Instead of making the battery voltage similar to the PV panel voltage, or the PV panel voltage similar to the battery voltage, now we use the maximum power point tracking to change the PV voltage to a value different from the battery voltage by using the duty cycle. Okay, so in the end, the maximum power point tracking function, it changes the PV array voltage until we reach the maximum power. Okay, so the maximum power point tracking or maximum power point tracking or MPPT is algorithm that included in charge controllers used for getting the maximum available power from PV module under the certain conditions. Okay, so the voltage at the PV module can produce maximum power, called the maximum power at a certain voltage, called the maximum power point or peak power voltage. Here, for example, in this example, let's delete all of this. In this example, at this point, at this voltage, give us the maximum power. So we need the maximum power point tracking to adjust the voltage at the PV array or the PV panel to produce this maximum power. So the maximum power also varies with solar irradiation and the ambient temperature. So the maximum power point tracking should know the solar irradiation or ambient temperature in order to know what value of voltage. Or if you don't know the solar radiation or don't know the ambient temperature, there is a different techniques used inside the maximum power point tracking in order to know the maximum power. One of these techniques is Pertrap and Observe method. In this method, what we are going to do, we have the start of the program. At first, the maximum power point tracking or MPPT or the maximum power point tracking, what does it do? At first, it increases the operating voltage. At the beginning, increase the voltage of the PV array. Now observe, is the power produced now greater than the previous power after it changing or adjusting the voltage? Is the new power greater than the older power? If the answer is yes, it means that we are on the right track. For example, if we are at this point and we increased the voltage, for example, to 15, and observe the new power. This is the old power here, old power, and this one is the new power. So we can see that the new power is higher. So we are in yes, we are in the increasing the new power is higher. So what will happen is that increase again the operating voltage and observe. So increase the voltage and observe. This is the old power and this point is the new power. Is the new power higher than the older power? Yes. So increase again the operating voltage. For example, increase now until after the maximum power point tracking at this point. So at this point, for example, if we go up, it will be higher. Okay. For example, here, this is point, we increased until we reached this point. Okay, let's assume we reach this point. So again, this point, the new one, is higher than this power. Now again, we increase the voltage after the maximum power, after the maximum power point tracking. So now the new voltage, the power here, is lower than this power. So what will happen is that, is the new power higher than the older power? No. So what does it will do? It will decrease the operating voltage. And observe, is the new power higher? Yes, then decrease again. Is the new power higher? If no, then increase the voltage, and so on. So it fluctuates. So let's delete all of this again. For example, at this point, okay, and we increased the voltage, for example, to this point, to the maximum power here. Okay, so it goes here. This is the older power and this is the new power. So is the power increased? Yes. So what will happen? Increase the voltage again. Here, this is the equivalent power. Is this power higher than the older power? No. Then decrease the voltage again. So again, it fluctuates. Go here, go back, go forward, back, fluctuating around the maximum power. So this technique is very simple, as you see in this figure. So it is one of the most popular maximum power point tracking methods in PV system. Here we apply a small perturbation is injected to the system, and if the output power increases, again we will do another increase in the voltage, and if the power decreases, then we will do the reverse. Okay, as we have explained now in the picture. This algorithm requires a few mathematical calculations, as you see here, just if conditions, which makes the implementation of the algorithm fairly simple. For this reason, the P&O method is heavily used in the renewable energy system. So in this video, we discussed the maximum power point tracking technique and what is the benefit of the maximum power point tracking charge controller, and we discussed that one of the algorithms used in maximum power point tracking. In another video, we are going to see a MATLAB simulation for a complete PV grid connected system, and we'll see the technique used inside the maximum power point tracking, and we'll see the different components and how to do the simulation inside the MATLAB program.